Find the volume of the solid that results when the region closed by the curve is revolved around the y-axis. We have x equals negative y squared plus 4, x equals 0, y equals 0, and y equals 2. So this time we have to think about things revolving on the y-axis. That means that we need our bounds to cut off about here and here. We see that in our problem with these y equals 0 and y equals 2. Y equals 0 is a horizontal line at 0. Y equals 2 is a horizontal line at 2. And that kind of breaks up our area here. X equals 0, this line here makes it so we're not taking the area of anything to the left to over here, only things to the right. The last thing that we have here is that negative y squared plus 4. This is our actual equation that we're dealing with. So if we look at our bounds C and D are like A and B. So C is our lower one. The lowest y value that we're going to be looking at is 0. It's this bottom piece here. So C is going to be equal to 0. Our highest y value is 2. So I know my bounds are C equals 0, D equals 2. The radius for this one is just like the radius for the other one. We are starting at the y-axis here, and we want this distance here. We would do right minus left. Our rightmost function is that minus y squared plus 4. Our leftmost function here would be y equals 0. And since we're taking away 0, it is just negative y squared plus 4. So for our function, r is negative y squared plus 4. Okay, so we have our volume is equal to pi times the integral from c to d of r squared dy. So pi times the integral from 0 to 2 of r is negative y squared plus 4, but we need to square that, dy. Just like in our other problems from our cross sections, I can do all of the work to do this. I would need to multiply out negative y squared plus 4 times another negative y squared plus 4. This is going to get me something in the y to the 4th minus a y squared plus a number, and then I can integrate that. After I integrate it, I can plug in my bounds. Because we have a 0 here, a lot of things are going to go away. But what we really care about right now is finding our radius, finding our bounds, and then plugging it into our equation. So we can always use a calculator if it's calculator active to then integrate for us in our problem. So the integration we should get, that number we should get, is going to be 256 pi over 15. So if we practice plugging this in, we should get something that's equivalent to this fraction. When we do this, we can do this by hand. It's just not necessarily needed to do by hand every time.